All right, let's get started with our official last lecture for for this section. And theoretically, we have one more, but the last lecture for everyone is going to be optional. Just going to be more things that I think would be helpful for you to learn that are just going to help you generally with your technical skills and stuff. So let's get started. How's everyone doing this morning? Is anybody doing anything different? Any new hobbies you've picked up? No? More radio silence week after week? You got a ticket? Oh, you got a ticket for Greece? Oh, when's that for? I hope that's for a long time from now, hopefully, so that you'll be able to safely take it after the quarantine. I hope so. Yeah, okay. We'll see whether, like, hopefully it doesn't keep extending, but we'll see when that happens. Um, just finishing coursework, yeah. So I hope people benefited from the fact that I just posted the rest of your coursework for this class, because you can theoretically just finish all of your work for this class now and just be done with it by like whenever you want. You could be done with this class in a day and then be like, I never want to see his face again. If you want to, you're welcome to do that. So you're good to go on that. The finals posted, so that'll be fun too. Cool. What have I been doing? I haven't really done any new hobbies. I've been trying to play some new board games. So I'm just trying to like figure out more things that I am trying to find more healthy things to be doing instead of just watching a lot of TV all the time. So like I got a new board game with my girlfriend. It's called Codenames Duet. It's like Codenames but for two people, and it's kind of cool. You get to like alternate giving clues back and forth, and you're both guessing and giving clues. So that's kind of fun. I've been watching. So I watched anime for a long time, like until I was in like high school, but I never watched Death Note, and I just started watching Death Note again yesterday, so that's been pretty cool as well. Um, when will Project 2 grades be posted? Theoretically, the TAs told me that they would be posted by this morning. I'm gonna ping them again and see what's going on. So I will just make sure that I'm updated on why they haven't been posted. They said they're almost done, I think, over the weekend. So like hopefully it's going to be done very, very soon. So I'll just ping them and make sure on that. I apologize for anyone who's waiting on those Project 2 grades. I can't I can't jump in and grade them now because it's just going to be unfair to people, because like if I grade some people's Project 2s, they're going to be graded much more harshly than the TAs would be grading them. So like I can't really step in at this point. So I think you'll ultimately appreciate that I'm not helping speed that up. But yeah, cool. Let's jump into lecture. Awesome. So today's lecture is a special lecture. So this is going to be just a lecture on general tips on industry success. So what that's going to look like is, why can't I see my screen share? So what this is going to look like is there's going to be soft skills and hard skills that we're going to discuss about how people in industry think, how you can think in industry to generally be successful. This is mostly going to be applicable for software engineers, but the soft skills are going to be super important for anyone going into any field. These are just general tips that I have that have helped me and other people I know find some success over the years. One question on that: if you have if you submit parts 1 to 3 on time and then submits part 4 and 5 late, would all of the homework get half credit or only the late part? That's going to be very hard for me to give half credit on only the late parts. Like, if I have a grade on Canvas for you, it's going to be really difficult for me to like go back over every assignment for every single person and like go over everything and try to see if like someone has resubmitted for something. In terms of complexity, if n is the number of students and k is the number of assignments, I'd have to do an O of n times k algorithm to look at every single one of those. So overall, I would have to say, unfortunately, what you submit is what you're going to get half credit on, basically. Or yeah, submit more than half for like 70%, and that'll be what I'll be grading. Sorry about that. I wish I had more time to actually look through everything, but it would just take way too much time for me. Cool. Couple announcements. Homework 5 is due Wednesday, so please turn it in as soon as you can, again, just so that I can finish grading ASAP. I got through most of homework 4 submissions this weekend. Took me a long time, so like again, I'm working hard. So thank you so much to the 12 of you, I think, who have submitted homework 5 already. That's really helpful. And as soon as you finish homework 5, please go ahead and submit that. The final exam is posted and it's pretty hard. I believe it's harder than the midterm. There are 4 interview style questions and the extra credit is also interview style. Well, yeah, it's 30 pages, but it's not 30 pages of questions. It's 30 pages where like 22 pages are blank space for you to write your answers. So it's not that long. I just left a lot of blank space for you. But yeah, overall, it's pretty hard. Spend a decent amount of time on it. You will not do well on this final if you save, only 3 hours on the last day for it. It is definitely going to take more than 3 hours. For sure, going to take more than 3 hours. And there's a reason it's a take home. I want you to try your hardest on this. It's an independent exam and you'll automatically get a 0 if you DM anyone asking for help outside of the general or final exam chats. Like, it's on the front page, it's on the announcement, you can't miss it. If you cheat on this final by asking someone else for help directly, then you are definitely going to get a 0, no questions asked. You can contact me privately, and you can run whatever you want by me. I may or may not answer. You can ask for help in the general and final exam channels where you can ask clarifying questions. And yeah, overall, take it by yourself, do it alone, etc. And then another note on the final: you can't submit like GitHub links, you can't submit HackerRank links or Replit links. All code has to be either screenshotted or copied and pasted or handwritten, whatever you want to do. Write it out in your actual final exam, or like put it in one merged PDF somehow. I'm not going to be clicking on any links. If you have a link, it's going to be a 0 for that question. So that's one note I wanted to say on that. And then all assignments are due on May 12th at 12 p.m. At 2 p.m. Sorry. And there are going to be no exceptions unless you have like a documented emergency for that. So even a minute late, if you submit anything at 2:01 p.m., then you're going to get a 0 on that assignment. And this includes the final. If you submit your final at 2:01 p.m., then you will get a 0 on it. And there's no exceptions to that. You're going to get a 0 on 12.5% of your grade. So please don't do that. Treat it as if your assignments are due at 12 p.m. And then if you have technical difficulties, you have 2 hours to resolve those. So just turn it in without exception at 12 p.m. maybe, or something like that. Cool. Couple notes, some more like logistics things. Today is the last required lecture. I'll do an optional lecture on Wednesday if enough people are interested in coming. In the chat, just tell me if you're interested, like say yes or say no, whatever you want. And I'll do a poll on that. If there's only like 5 people who are gonna come, then oh, sorry, let me mute everyone. Cool. So if there's only like 5 people who are interested in coming, then like I'm not gonna do the special lecture. But if there's a lot of people who are interested, then I'll definitely do an optional lecture, which will just be more stuff about how to succeed in the workplace or something like that. Cool. Okay. You can also, given that today's the last lecture, I wanted to allow you the opportunity to stay in touch with me in whatever capacity you want. So you can reach out to me about anything from serious things to super casual things. So job referrals, memes, cute animals, interview prep, resume review, whatever you want, just reach out to me. Here is all of my contact information pretty much. Yeah, you can reach out today. You can add me on Facebook or LinkedIn or Instagram or all of the above. Um, so there's my Discord, LinkedIn, Facebook, Instagram, and even like personal email. So you can reach out to me on any or all of those. One thing I wanted to say about the Discord is I can also set up a Discord server so that we can stay in touch as a class. I found that helpful for old interns and stuff. So overall, like I can do, so I can set up a Discord for us just so that we can all stay in touch as a class, if that would be helpful. I'll probably do another poll on that on Slack. If you don't want to, then we don't have to bother. But yeah, overall. Also, who took facebook.com/Sresht? So that's actually pretty funny that you mentioned that. I had facebook.com/Sresht, but this is kind of a flex because you can actually only Facebook employees can have usernames that are less than are fewer than 5 characters. So this is kind of a flex because no one else in the world can take SRES, and other people can take Sresht, but no one can take SRES. So yeah, anytime you go to like facebook.com/something less than 5 characters, it's guaranteed to be a Facebook employee. So that's kind of fun. That's why it's SRES there. Yeah, and other than that, if you just look up Sresht on any social media, that's going to be me most of the time. Cool. I wanted to, do you have to give up that name if you quit? No, I get to keep that name for eternity, which is great. So I'm gonna be that, I'm gonna be /Sresht for the rest of, as long as I want to be. Cool. I wanted to update people on my next semester. The update is, unfortunately, I don't have much of an update yet. My next semester is not set in stone, but there is a good chance that I will not be teaching CS 490 next semester, but it is technically a possibility. However, if I'm not teaching, you're still going to get a teacher who's taught the class multiple times. And I've never taught the class, but the person who would probably be teaching has probably taught the class multiple times in the past. So that's something that I wanted to say for you. And another thing I wanted to ask is, if you have a second, if you could leave a review on my external Rate My Professors, even if it's negative, that would be kind of helpful. It's not something that like Facebook cares about or anything, but it's more just for my own sake, so that if I end up teaching CS 435 either at NJIT or somewhere else next semester, then students can see a perspective from other students instead of just like taking my word for it about whatever my class is going to look like. I want them to know the good stuff and the bad stuff. So like even if you don't have nice things to say or whatever, if it's productive, just let other people know so that you could help them by giving me that rating. There's one student who gave me a rating and it was like super nice, but it was in February, so it's been like 3 months. So go ahead and leave your rating on there. That would be super helpful on there as well. One last thing is, please don't post any questions or solutions from this class don't share them with others. I might reuse this content for next semester, so like please don't post the solutions, please don't post the questions, just because I don't want some students to have like an unfair advantage versus other students or something. That's just one ask that I have. I'm not going to recommend that you share it with NJIT students either, but please don't put it on the internet for anyone to see. Oh, you can use Git. That's fine. Git is totally fine. I'm just talking about the actual like question pages. Like, for example, like don't post like the homework for assignments and the homework for solutions and stuff. You're welcome to show off like your balanced AVL tree and your Dijkstra's algorithm on Git. That's kind of the point of why I made you put it on Git so that you can actually have it on your resume. So that's totally fine. Cool. So those were a lot of announcements. And I hope those were helpful things just for general overall things. Today's objectives are going to be threefold. We're going to cover a lot of material today. We might end up going overtime. So today's objectives are going to be to understand how industry operates differently than academia. How are the things that are expected of you in an engineering setting going to be different than what you learn in academia? We want to evaluate the ways in which you can supplement your learnings in this class with industry standards. So what that means is, how do we take what we've learned in this class and elevate it to the next level? And then we want to iterate on the scalability and efficiency of our previous work in a way that you'd be expected to do as an engineer. So we're going to go through a huge example of that, and I'm going to do some live architecting with you guys, and you're going to act like you're my team of engineers, and you're going to help me architect a new system based on things that we've already done. So well, technically it's the second to last time. For the second to last time, why do we care? Why is today's lecture going to be important? This should theoretically be one of the easiest why do we cares. So if anybody has thoughts, please raise your hand or type something out. Yeah, it's definitely tying everything we learned together. So it's tying things together, not necessarily in terms of, there's not going to be like the master algorithm that uses heap sort and radix sort and like Dijkstra's and whatnot, but it's going to tie everything together in terms of real life applications. So we're going to talk about what real life applications looks like and how we can take the theoretical stuff in our class and like actually apply it into practice and what it looks like when we apply it into practice. What else? Anything else? It's specifically prepared to be used in industry. Yeah. So this is going to be useful tips in industry. Anything else? Understand the industry? Sure. So basically understanding expectations of what is expected of a new engineer. Sure. And I would say for engineers and non-engineers. So I've also catered this to about half of this talk to people who aren't going to go into engineering. So half of this talk is just going to be useful advice for people who are not going to be software engineers as well. And can I get one more suggestion on what might be helpful in this talk and why we care about it? No, no one else? All right, I will move on then. So a couple things that I wanted to point out here. Everything that you learned in this class, even if you got everything exactly right, missed 0 points, did every point of extra credit, and got 100%, is a prereq to being a good engineer. If you got 100% in this class, that means you're on the right track to getting a good start to being a good engineer, but it does not mean that you're going to be a good engineer. I wish that professors managed my expectations correctly and properly when I was in school. They didn't do that, and they didn't have the ability to do that because they're very academic. They haven't been in industry for many years and potentially never. And I want to give you I want to do my best to give you that opportunity because I have a very unique skill set. I'm tying academia together with industry, and that's the point of the EIR program. So I wanted to give you that opportunity to manage your expectations properly and what is going to be like school and what's not going to be like school. Spoilers, very little in industry is going to look like what school looks like right now, for better or for worse. And then being a successful engineer means thinking of multiple dimensions of a problem. You can't just jump to the right solution. You can't just start coding as soon as you see a question, because there's no best solution most of the time. Or at least it's not that obvious what the best solution is. There's a lot of dimensions that you have to think about. And then for more senior engineers, this is one of the most important and difficult interviews to pass. They're going to ask you to just architect a general system, and they're going to see how you do it and how you think about systems architecture. So this is going to come up in interviews if you're an engineer later on. And then also this is going to be super close to what I ended up doing every day for my job as a software engineer. So I wouldn't say every day, but I've probably done something like this maybe 30 times in my career over the course of like 2-3 years. So 10 times a year, pretty often that I'm going to be working with a team of engineers and leading a systems architecture design and talking about how long it's going to take to make everything. Here's a little bit of a pep talk because it's my last official lecture. Getting an A in this class does not mean you're going to be an amazing engineer. Don't get that in your head that if you have 100% in this class taught by a Facebook EIR, that you're going to be like the best engineer in the world. That's simply not true. Success in this class and success in algorithms and data structures in general has very, very little to do with being a fantastic engineer. And on the flip side of that, failure at this class. So if you get a D or an F or a C in this class, that doesn't mean that you're going to be a bad software engineer. It has very little correlation in my experience. Like some of the best engineers I know are terrible at algorithms, and that's fine. However, success in this class just means that you're making a good start towards preparing for technical interviews. So a lot of the success in this class was tied directly to your performance in a interview-like setting. So if you're great at those interview-like environments and you're looking at the final exam questions and you're like, I can solve this in 20 minutes, then you're on a great trajectory towards passing technical interviews. So that's all that being good at this class means. So most of you have seen this meme already. So Max Howell, who invented Homebrew, he wrote this tweet about how 90% of the engineers at Google wrote software that used software he wrote, Homebrew, but he couldn't invert a binary tree on a whiteboard, so Google told him to fuck off. So they didn't give him a job offer because he didn't know how to invert a binary tree. That was a question that I asked you guys in recitation. And like this was something that he struggled with and he got rejected from Google, even though most Google engineers use Homebrew. So this is just another point of like very successful people. A lot of people I know who are great engineers are not good at this class. So don't get demotivated and don't think that you're bad at engineering if you didn't do well in this class. And then one last thing that I wanted to talk about is COVID-19 and the industry. This is probably one of the most common questions I get from people outside of this class, which is, what are my chances of getting a job? COVID is going to make it harder for a lot of people to find jobs, at least in the short term. I don't want to lie and say it's going to be fine. It might be harder. There's been a lot of layoffs. I think 10% of the jobs in this country don't exist anymore. However, you're fortunate to be in an industry that can theoretically work remotely. We are in a fortunate position where engineering, especially software engineering, isn't as deeply affected as a lot of other industries because we don't necessarily have to go in person and it's easier for us to switch remote. Obviously, that's not true for every job in software engineering, and it's not true that everyone here is going to be a software engineer, but that's just one thing that we have a little bit of an advantage of. Don't be discouraged. Continue to apply to as many jobs as you can. Another thing is big companies are still hiring, and a lot of big companies are hiring aggressively now. So Facebook, Google, Microsoft, and Amazon, I'm pretty sure all four of those are hiring aggressively. So don't be afraid to interview there. There's literally nothing to lose at this point. Like, worst case scenario, they're like, apply again in 6 months, and you'll get some free interview prep. You can interview out of your own room in 3 hours, and you can be like, I want to interview tomorrow. And worst case scenario, you get rejected and you learn from it and you figure out what an interview style environment looks like. So I really, really recommend applying to all these different places. That is the end of my pep talk and the beginning of today's lecture. So how do I feel prepared for my first job? The honest answer that I have to that is that it's almost impossible to feel like you're going to hit the ground running. And very, very few people I know actually hit the ground running. I had 10 interns. One of them hit the ground running in a way that I had never seen before. And that's because his major was software engineering and not computer science. And that's very, very rare. It's not common to see that. And the reason behind that is the tools you use at one company are going to be wildly different from the tools at a different one. They might not be public, and there's almost no chance that you use them at NJIT or at any college. It's just not something you can feasibly learn. However, one thing that is the same is the overarching traits of what a successful engineer is and how a successful engineer thinks. So I'm going to go over the traits of successful engineers, both qualitatively and quantitatively. So the traits of a successful engineer, in my opinion, this isn't a overarching, like this isn't the only traits, obviously, but these are just some things that I thought of. So the qualitative skills are going to be that you can incorporate and internalize feedback very quickly. You can be flexible with colleagues about projects and deadlines, and you can proactively ask for help in unknown domains. We're going to talk a lot about all three of these points, so don't worry too much if you don't fully understand what those are. And then the quantitative things, the technical skills, are that you want to front load scalability, you want to architect software for with flexibility in mind, you want to test thoroughly, and you want to drive decisions with evidence. So again, one thing that I wanted to talk about are that these are also for non-engineers. So these are traits that are going to drive success for any employee at any company. So if you're not interested in being an engineer, you don't have to worry about these. These are pretty much only for engineering or like maybe PM, TPM, very technical roles. But the qualitative ones are going to be applicable to any industry and any role, basically. Any questions so far on anything that I've covered? All right. All right, this slide got a little messed up. But anyway, as you get more senior, qualitative traits start to matter way more. And the weight of them during your package or when it comes to performance, when it comes to getting a new job, is going to be super important. They're also much harder to teach. It's harder to be like, hey, this is how to be a good engineer or a good person to work with qualitatively. A lot of these are skills that you just have to work on over the course of many years. If we have time today, I'm going to be happy to provide some advice on those bullet points. If I don't have time, it's towards the end of my lecture. I've written them all out. So there are slides on it, and I highly, highly recommend you read them. This is probably some of the most helpful advice you'll see in this class, and hopefully some advice that not everyone gives all the time. I had a few students who read it last night and they were like, wow, that felt really helpful to me. I'm going to follow that advice. So I really hope that you can do that. So again, here are the qualitative traits that I talked about. Don't worry too much if they don't make sense to you right now. You can read more detail about them later. Cool, this slide also got messed up. Oh, Sean, what's up? I can't hear you. Can other people?
Is this better?
Yeah.
Okay, cool. Sorry. I was just saying it's really awesome that you're bringing these kind of things up because it is something you wouldn't think about unless you've already been in a job before. But one question I was considering is um, like, how do people work on these kind of things without experience? Like, how do
On
you
the
take it
qual
to heart, that kind of thing?
Do you mean the qualitative traits?
Yeah, like accepting feedback and
Yeah,
um, seeking
that's
or asking questions.
that's a great question. And I'm gonna give you a little bit of actionable advice towards the end. That will be things that you can go into your job on day one with, and just try to follow that advice, and that will bring you pretty far in your career. This is not just for full-time employees. This is definitely true of interns. And after making this slide deck yesterday, I decided that I'm going to share this slide deck and give this lecture to every single intern that I have from now on, because this is just going to be overall actionable feedback. And I've broken it down so that it's literally just like a recipe, like where you can be like, cool, today is Monday. What should I be doing on Monday? And I've given you like an actual breakdown on what to do. So you don't have to think too hard about it either. So I'm trying to break it down into real things that you could do without just being wishy-washy about it. We'll go over that towards the end. The other thing I wanted to say is quantitative traits are the things that I talked about are going to be critically important towards the beginning of your career. So at the beginning, the qualitative traits aren't that important. The qualitative traits are basically don't be a dick, be a convenient person to work with, and just overall be someone that other people want to work with and want on your team. The other things that we talk about, like receiving feedback, being able to work with others, and deprioritizing things, those matter way more towards, well, as you get more senior in your career. So in my boat, those are starting to become way more important for me than the quantitative traits are. But at an entry level position, quantitative traits are going to be very important and more important in some ways than qualitative traits. So that's what today's lecture is going to be about. We're going to talk about these 4 points: front loading scalability, building flexibility, testing thoroughly. Well, we're not going to talk about testing. I hate talking about testing and I'm bad at it. So we're not going to talk about testing, but we're going to talk about everything else. And we're going to drive decisions with evidence as well. We're not going to talk about that much either. We're going to talk about, most of today's lecture is going to be these first 2 bullet points. But I can talk through how to test things and how to drive decisions with evidence as well. All right. So hopefully we all remember this. This question where we implemented Dijkstra's, we put treadmills in the maze, and we decided that we're going to implement Dijkstra's algorithm. There's a bunch of typos on this slide. I'm sorry about that. I guess I was really tired. I didn't realize there were so many typos, but you get the gist. We're implementing Dijkstra's to solve the maze. Now, the first partner exercise that I have for us today is many of us used an implementation of Dijkstra's that involved initializing D node, so the distance from our node to the end, to negative infinity. What are the downsides of doing this in an engineering sense? Like, what are some real life drawbacks if we end up doing that? And what are some other considerations outside of that? Like, in just a real world implementation that uses pathfinding, what are some differences between what we did in academia and what we would actually do if we were working at Uber or Google or something like that? Anybody have any thoughts? Take a second to work with a partner and then we can come back together. Okay, cool. Anybody have some thoughts? Okay, Demo said something interesting, which is that the size of the node list could be gigantic and it's not really doable to try to visit all nodes. Definitely. That's what I was getting at mostly. Someone messaged me privately and they said that the cost of initializing to negative infinity is huge. We might not have perspective of the whole map. So again, do any of us remember what a node is in Dijkstra's? Not necessarily in our maze, but in general, what does a node represent in a pathfinding algorithm? Anybody remember that? No? No one remembers what a node is? Yeah, we did 12 weeks or 6 weeks of pathfinding in graphs. Yeah, like a cell in a maze, definitely. Others, that's a great point. A place that you can visit. So what do we call a place that we can visit? A node just represents a location. So in pathfinding algorithms, locations are just nodes, basically. Okay, it feels like a trick question where the answer feels too obvious. Sure. So a node is just a location somewhere that exists. And if we have to visit every single location before we run an algorithm, that would be so bad. That would be crazy. So let's talk about that in the sense of Uber. If you have distinct locations and you're initializing everything to negative infinity, you can't process you have to run Dijkstra's only after only after you've processed every single node in the entire graph. And in a real world example, can Uber process every location in the entire world before finding your carpool route? Obviously not. That's not something that is even possibly theoretical. Like, we shouldn't be looking at London when you want to look at a carpool route from New York to New Jersey or something like that. So that makes no sense. And running your Dijkstra's algorithm in the sense of like an Uber implementation would be a terrible idea. Every carpool would take like billions of years to run if we ended up using Dijkstra's the way we implemented it in class. So let's talk about some other considerations while we're at it. So the other considerations we have are the locations that we have access to are going to be dynamic. So for example, the routes that you see when you're doing an Uber pool match in London are going to be different than the perspective of the map that you have when you're in New York City. And that might even be different than a different Uber pool request from a few streets away in London. Even like 2 or 3 streets away is going to have a different perspective on the map. None of these calls should have perspective over the entire map of all of Uber's like possible drop-off locations. You can cache general locations, sub-locations, and pass them into a map. That's true, but you're going to end up doing that on the server. You probably don't really want to cache it or anything like that because that's going to be a lot of space that you're storing without not a lot of overlapping subproblems. So you probably just want to use like some lookup to do that, and the server will smartly decide what to cache and what not to. So in the real world, like I said, you are going to get the approximate set of nodes for a given location using some sort of server communication. So let's talk about flexible architecture when we do that. In the real world implementation, what are some possible parts of a pathfinding algorithm that we might want to change? So what are some things that we would want to swap out potentially in the future when we're making some changes? I know this is a vague question, but if you have any thoughts, then feel free to share them. Maybe the ability to detour on the fly. Maybe. So maybe it's instead of A to B, we might want to do A to B to C. So what are we changing here? What is that detour going to look like? What does this represent? I would say this represents the goal state. So when do we finish? So that's definitely true. When do we say we're done? So more broadly than just saying able to detour, maybe we should just say one thing that we might want to change is when we say that we're done with this. So that's definitely true. Any other thoughts? No one's raising their hand yet. Okay, I'll move on. If this was tricky, how can we get there? Okay, sure. Possible routes. So what this looks like is the nodes and edges in our graph. Definitely. So what do we consider as a possibility on our route to get there? So definitely true. So let's talk about a few more. What about the type of pathfinding algorithm? So we have A-star, we have Dijkstra's, we have Bellman-Ford, Floyd-Fulkerson. There's a lot of different pathfinding algorithms. What if we just want to swap one out without changing the rest of the program? Let's talk about the node to process. Do we want to process the k nearest nodes? Do we want to process all of the nodes in the city? This is similar to what Matt was saying. What the goal state is, which is similar to what Eric was saying, when have we found, should we end when we found the local optimum or the overall optimal? Should we find something that's pretty close to our heuristic or something? How are the edge weights determined? Are they the distances between two places, the gas cost between two places? What is the user actually shown? All we did was print to a console. That's not going to be useful in the sense of like a web app or like a Android app. So when do we start looking for a route? What do we show when we've done that? What do we show when we found a route? What do we show when there's an error? All these things are actual parts of our implementation that we might want to change on the fly, that we might want to iterate on. Any questions on any of these? Cool. Quick pop quiz. What type of pathfinding algorithm are we going to end up using somewhere in, like, for example, Uber? What is Uber going to use for pathfinding? Do we remember that? One that uses heuristics. And what do we call one that uses heuristics? Yeah, A-star. So this is something that Uber and Google Maps are going to use. Just for a little bit of information, most places just use a heuristics, and so they're just going to do a naive implementation of A-star, maybe use an API for that or something like that. Yep. Cool. So let's figure out together what architecture we might use. And architecture is a scary word for most of you. You probably haven't taken many systems architecture classes or like software architecture classes. And don't forget that it's not easy to say that this is a right answer or this is the perfect answer. It really depends on what our goal is and what we think we're going to expect to change and what we have time to future proof. And in the ideal world, we want to make sure that we're scaling out everything that we can. But we might not have time for that in a real engineering sense. So this is sad. My slides keep getting messed up. I have no idea why. But we're going to talk about the model view controller architecture and hierarchy. Raise your hand if you've heard of model view controller before. All right, four-ish people. Okay. MVC is a very, very common architecture that we use in software engineering. This is incredibly used. This is used all over the place in industry, and you'll see these terms all over the place. So a model provides us all of the backend logic. So model is going to provide us any type of work that is going to be used in the backend. So that's going to represent, for example, the types of pathfinding algorithm, the nodes to process, the list of nodes that we want to process and how we want to process them. Do I have questions from Kandar and Pablo, or was that just a vote for who's heard of it? Feel free to not raise your hand if you don't have a question. Cool. So controller logic accepts inputs from the model, processes it, and then gives it as a useful format to the view. So this might be how the edge weights are determined. So this might be something like, hey, I have this graph, it's super helpful, and I have these APIs that the model has, but what do I want the edge weights to determine? What are they actually going to be? What the goal state is. How do we say when we found the overall optimal? When do we return that we're done with the algorithm or something like that? And then lastly, how do we find, or like, are there any heuristics? That's all stuff that ends up happening on the controller side as well. And then the view logic is what it sounds like. It's what the person is actually seeing on their screen. So it accepts inputs from the controller and then converts it into a human readable format. So what do we show the user when we start processing a route for them? What do we show the user when we found a route for them? When do we switch parts of the view? This is a really important one. So how do you switch from, oh, we are processing a route to now we actually have a route and we want to show the user something else? So that's going to be super important as well. So, why do I have the same slide twice? I don't know why this slide exists twice, but I'm going to skip over that. So one thing that I wanted to talk about, oh, I see, okay. So one thing that I wanted to talk about here is this last bullet point specifically. How do we keep state? How do we switch what part of the flow we're on, and how do we change it depending on the process type? So there's two different options we have inside of here. Someone messaged me, why is it MVC instead of MCV? I don't know. People just call it model view controller instead of model controller view. But I don't know, it doesn't really matter. Most architectures have all three of them. So there's a lot of options on how to keep state and how to like preserve state back and forth between these different options. And we're gonna go over one of them here. And it's called PubSub, Publisher Subscriber. So what that means is it's a quick and dirty serverless option. Basically, you have one class that sends updates. So a publisher updates everyone whenever it has an update. It doesn't know or care who needs the update. So let's say we have a change in state. Maybe we are going from awaiting user input to processing route to found route or error or something like that. Whenever we have a change in state, the publisher is just going to jump on a loudspeaker and it's going to talk to the entire city of New York and be like, listen, I have an update. Anyone who cares is going to want to hear this right now. And it doesn't care who listens. It doesn't know who listens. All it knows that it's going to update other people. And then subscribers say who they choose to subscribe to and what to do with that information once they have it. And these guys don't know or care where they get the information from. So this is like, for example, we're watching TV. If we're watching TV and we see an important broadcast, we don't really care who's saying the broadcast most of the time. We just care that we're getting that important information. So once I get that important information, what am I going to do with that information once I've internalized it? So if I get found route, maybe I'll open up a new flow. Error might open up a page to report a bug. Different things will result in different actions that I end up taking. So most of the time in our MVC model, what is the publisher going to be and what is the subscriber going to be? You can say M or V or C. So what is the publisher going to be most of the time? Who's going to be doing the publishing of new info? The model, yeah. So the model is the one who's determining changes to our system. So the model is going to be making most of our changes. And then you sometimes have the controller doing that too. But most of the changes are going to come from the model. And what about the subscriber? Who's going to be subscribing to the changes that the model or sometimes the controller makes? The view is going to be the main one, but again, sometimes the controller. So sometimes the controller is going to be like, oh, okay, so we might actually want to do something with this state change that the model has said. So like I said, that's quick and dirty. What is the key difference between model and controller? So the model does the back end things and doesn't care about anything to do with the front end. The controller is the guy who talks in between the model and the view and maps them together and basically says, how do I connect you to? How do I translate one language to another? So let me think of like a real life example of this. This might be like, for example, let's say that there is someone in a store who, like, let's say there's an accountant at a store. They're going to be the model. They're the people who work behind the scenes to figure out how the store is going to operate. And then the people all the way at the front are going to be the salespeople, the people who are selling things to people. So the controller is going to be the people who actually bridge those two people together, who are going to bridge the accountant and the salesperson. So this might be someone like a consultant. This might be someone like I don't know, a cashier, someone who is able to speak both languages and is able to relay the information back and forth between the two different people. So it's not that necessarily that model represents the data. The model might still have a lot of things like AI in it. It might have machine learning in it. It's going to be anything that outputs data that the controller generally uses. So that's generally how it works. Like the model just manipulates data, raw data, and presents it in a usable way to the controller, whatever usable means. And then option 2 here that we have for holding state is database mapping. So a model might update the database whenever it has an update. So whenever we found a change in state again, we just write it to a database. And then the subscribers this time just do some polling on some frequency. And they figure out when these updates take place. And it totally depends on how urgent the data is. There's not like it's not like every time every single subscriber is going to be polling every 500 milliseconds. It might just be like, hey, cool, like when we're processing a route, we should probably be polling every 500 milliseconds. But if we're just trying to see if there's an error in the background, then we might just poll every 10 minutes or something like that. Depends on how urgent it is overall. So again, we poll on some frequency. Once we get the right thing in the database, then we act on that using these different things. So again, these are just the same things as before. The model is still going to be the model. The subscribers are going to be the view, and then sometimes the controller. Actually, no, this should never be the view. Sorry, this time this should only be the controller because the view should never be doing database calls. The view should be like, given some information, what do I do with it? Instead of necessarily going to the database directly. Cool. And then I have another question for us. This is going to appear on your final, so make sure you're paying attention for this. But when should we use existing APIs? I've talked a lot about what scale looks like at a company like Uber and why we shouldn't use something like Dijkstra's. So when should we use something like Dijkstra's? If we can use certain characteristics, let's say, about our nodes to do a more efficient, if we can use certain characteristics and do a more efficient but more complicated algorithm than Dijkstra's. So for example, maybe we have v log v instead of v log v plus e log v. Like we're just doing something complicated and uses special characteristics of our data. Why should we even consider using Dijkstra's algorithm? Why would we ever do that instead of taking the more efficient solution? Work together with a partner and raise your hand if you have any ideas. Raise your hand if you have any thoughts now. All right, Kandar, what's up?
I was thinking, let's say UPS, it has a hub,
Uh-huh.
and the other hubs represent the other nodes that you want to get to, and you want to find the shortest path to only those nodes.
Okay.
So you might want to use Dijkstra's in that case, where you only have one starting node and it finds the shortest paths to all the nodes.
So you have some like limited scope that changes, like it's not that big of a scope.
Yeah.
Okay. George, did you have any thoughts as well? You can type it out if you want to as well. In the meantime, oh, sure. Go ahead, George.
I was thinking maybe if a property of the graph is that the destination is always going to be like something really close, like 2 nodes away, you could
Okay.
save on overhead by just doing Dijkstra's.
Okay. So if the graph is small, there's going to be a minimal gain with the efficiency. Sure. Okay. And then I have a few more thoughts here. Jenna, do you want to share?
Yeah, so I was just thinking, like, if you have like such a complicated algorithm, it might just be like very difficult for people to like understand in the future. So it'll be harder to like improve upon and things like that, even if it does help with efficiency.
Okay. Great. So if you have a really complicated set of logic, then it could be hard to read and it could be hard to iterate on. Sean?
Would it be something like saying that, Dijkstra's is tried and true, and like you might have this optimal route algorithm, but maybe there is a bug in it and you don't know, and trying to trace that back would be pretty difficult.
Dijkstra's is tested, but our solution is probably buggy. Is not. Okay. And then I saw one more, which Patika, did you want to share your thoughts on that?
Yeah, I just think it's because Dijkstra's is easier to implement, and I think it's going to be efficient enough in most cases. So we wouldn't really need to like work with a much more complicated algorithm.
Makes sense. Yeah. So what are some, like, just because it's easier, is there a reason why we'd want to take the easier route most of the time? Like, why would a CEO of a company want you to take the easier route, even though it's a little less efficient? Go ahead, Patika.
Uh, Probably because it's going to take less time to implement. So like you're going to spend less time working on it, and then you could work on other more pressing items.
Exactly. So less time to implement and more features. Exactly. So if you have a few pretty good features, it's better than having one amazing feature that's super fast a lot of the time. Sean?
Would we still say this is kind of contextual, just depending on what needs to be achieved, depending on the company?
Definitely, yes. This is contextual. This is why we would consider using Dijkstra's. This isn't to say we should definitely use Dijkstra's. So there's definitely a world where we might be like, oh my God, we have to use the best pathfinding algorithm. It's okay if it takes us 5 months to implement this algorithm. That V log V saving is going to be so important to us as compared to using Dijkstra's overall. Make sense?
Yep, thanks.
Cool. And now let's go down here. So a couple things that we want to talk about. Most of you mentioned what all of this is. So if the data ends up changing at some point, then we'd have to rewrite everything, which is going to cost a lot of time and money. And it's going to be in the form of expensive engineering salaries. Engineers are not cheap. I get paid a lot of money just to come into work. So anytime that I'm wasting even a few hours of work, they're paying me a lot of money to not do something that the company cares about. So anytime we have to rewrite a lot of things, that means we did something wrong. Engineering time to develop a complicated sorting algorithm might not be worth it compared to investing in something else, like Patika mentioned. the algorithm might end up being really fragile, which means we might have to end up spending a lot of time testing it. So like Sean said, we don't trust it. We know that we trust Dijkstra's. If we implement an API that already has Dijkstra's, then we don't have to test it. We can just assume that it's well done, and then we're probably not going to have bugs. And it's still going to require a lot of continuous upkeep and testing, the way that an open source technology probably won't. And then efficiency is important, but readability and simplicity, like Jenna mentioned, are far more important most of the time. So efficiency is cool, but like the cost of, an extra server is not that much. It might be like $100,000 to a company one time, and then you have an extra server for the rest of eternity. But readability and simplicity are so important. Those are not things that go away. Those are not costs that are going to be lessened. So most of the time we might sacrifice slightly less efficient algorithms for readable and trustworthy code. So again, this is part of why, for example, we don't use lambdas. This is why we don't use ternaries. This is why there's no functional programming. So these might be slightly more efficient, slightly less efficient, etc. But these are actually going to result in more easy to read code and more flexible code. Have I seen teams that develop APIs in Facebook? I'm very confused by that question. I think every team at Facebook develops APIs. Like most of my job is developing APIs. Do you mean like open source APIs, or like, because an API is just a method, right? Like obviously all I'm doing when I go to work is developing methods. So did you mean maybe like external APIs or something? You might have
I basically I thought that most I don't know, I'm new to this, so I thought basically you guys use the methods to develop something, and there are teams that create those methods, but I'm totally wrong, I guess.
Yeah, so like, I mean, you can't program without creating methods, right? So like, whenever you are creating some new flow, you're gonna have a method, and a method is just an API.
Yeah, you come up with a solution. Okay.
Yeah, so like every team creates APIs. If you're talking about open source APIs, there are very few teams that end up creating like Litho or Node or React APIs or whatever, but there are teams that do that. And I've worked with teams and open source repos and stuff, but it's pretty rare for me to do that overall. And yeah, you might see some ternaries slip through, but you're not going to see a lot of them, mostly because, again, it's harder to read. You don't want to have too many of them because it's just a lot easier for people to onboard onto a new team if you're expecting all the code to look like. Cool. I have a question. So I can go into a whiteboarding exercise. I can do a whiteboarding exercise for hours. I don't think I want to do that right now because we only have 17 minutes. I was thinking I'll just do that on Wednesday for our next lecture. Does that sound okay to everyone? I'll record it and still put it up if you can't watch it. But I'm thinking I'll just spend a lot more time on Wednesday actually doing that. Cool. Let's actually do that. One thing I wanted to say about this is I have literally done this on an actual whiteboard with teams of 4 to 5 engineers, maybe 20 to 30 times at work. Last year alone, since September of last year, in 3 months, I led 3 architectures. One of the architectures I led was for the entire Facebook app. And it wasn't obviously like all the features, but it was for the navigation of the new Facebook app. And there are some changes coming for navigation, and I led the architecture of that with another engineer. So like, this is stuff I do every day, and I want to do it live without prepping. So on Wednesday, I'm not going to prep for it. I'm just going to pull up a blank sheet of paper and start doing architecture. I'm going to do it with the entire class. I'm going to do it as a team, and we're going to do it together, because that way we can get practice with how to actually think about these problems and how to think about problems at scale. Again, it's not going to be tested or anything. It's just going to be really, it's going to be fun, and it's going to be, it's going to feel like what you would actually be able to see in real life. So I hope you come on Wednesday. It's not going to be tested or anything, but it's going to be a cool lecture. And it's going to feel like we're working together and not like I'm teaching you. So hopefully it feels like it's something that you're going to prioritize even during finals week. It'll be like a good hour, 20-minute break in some ways, and it'll teach you a lot theoretically. Let's go into our qualitative traits, and I'll wrap up the lecture with this overall. Oh shoot, now I have to come up with a different daily quiz question. I'll come up with something on the fly. Cool. So some qualitative traits that I've already talked about are obviously as you get more senior, these matter way more, but they're also way harder to teach. Actually, I'm going to pull up my other slides. These are not as weirdly formatted. Oh, there we go. There we go. Okay, this looks a lot better. So I'm gonna go off of this. Cool. So these matter way more, but they're also much harder to teach. So I'm going to give you some actionable feedback for all of these bullet points that will be a little easier to comprehend what I'm talking about. So again, the 3 qualitative traits that I want to talk about today are incorporates and internalizes feedback quickly, is flexible with colleagues about projects and deadlines, and proactively asks for help in different domains, in unknown domains specifically. So the first thing I want to talk about is internalizing and incorporating feedback quickly. If you have been tuning out for this lecture, pay attention now. It's going to be the next like 10 minutes are going to be things that hopefully change your perspective on how to be successful in industry. And these are the things that I do in my real life. So like, these are not things that I am like necessarily trying to make up on the spot. These are things that I have directly found success by doing. 3 big bullet points about how to do this properly. Set up weekly meetings with your manager and mentors or other senior engineers that you work closely with. So this doesn't have to be engineers, it could be anyone senior who is going to be a source of guidance for you. Set up weekly meetings with them. Start each meeting with 10 minutes where you ask for feedback and give feedback on how they can help you grow your career. So obviously give them feedback on how they can grow their career when it's relevant, but the most important part is how they can help you grow your career. Don't focus too much on helping them grow, because there's other people that they're going to work with to help them grow their careers. But focus on what you need to be successful. And the important part here is you should be doing this every single week. 30-minute meetings with your manager, with your mentors, every single person you work closely with who is more senior than you. Set up a meeting with them and spend 10 minutes asking for feedback on a weekly cadence. So as you grow older, as you grow more and more senior, as you get used to hearing this feedback on a weekly cadence, you're going to get to recognize your own gaps and what you need from people more frequently. So as you go in, you should be able to share your own thoughts more and more frequently. At the beginning, you're not going to feel that as much. So to help you with that, you should keep some sort of work diary where you can keep track of what went well and what went badly this last week so that you have talking points for your weekly meeting. You should do this every Friday before you leave for home. So before the weekend comes, just write it in your notebook. Write 2 things that went well this week, 2 things that went badly. And the well things are equally important as the things that went badly. Why do we want to keep track of what we did well? Anybody have thoughts on why doing things well is something we have to keep in mind? Okay, those are the 2 reasons that I was thinking of. Adarsh mentioned performance reviews, which result in raises and promotions. Definitely true. Mental health. So Matt mentioned keeping motivation. Definitely true. It doesn't want it. You shouldn't feel like you are just in this state where you suck at everything, because it's usually not true. And Jacob said you can replicate the steps you took. Definitely true as well. You want to be able to say, what did I do correctly in the past, and how do I make my mistakes or the things that I'm bad at better over time? And you can see your improvement over time as well. Definitely also important to think about that. And then the last thing I want to talk about is this will help you naturally do this. If you're getting positive and negative feedback every week from your mentors and managers, then you're obviously going to start responding to negative feedback without being defensive. Um, this is a really interesting point. I have responded to negative feedback defensively before. I have had managers who don't take negative feedback very well. I've had a lot of issues with this, both on my side and other people's sides, and it never works out well for anyone. If you are defensive, your manager is going to be like, okay, cool, you're being immature. You don't know how to internalize feedback properly. And if they're being defensive, you're not going to change them. So don't bother trying. It's just going to make you less likely to give them negative feedback. The best managers I've had in my career are the managers who I was like, look, you're one of the most senior people I've worked with, but that was really shitty what you did. I wouldn't say those in those words, but I'd be like, I had a problem with how we handled this situation. I think we should have handled it this way. And then those managers come up to me and they're like, thank you for letting me know that. Not that many people let me know those things so straightforward. And often I get rewarded for giving them that feedback so candidly because they recognize their own gaps. So that's just something that I wanted to say about. Another thing to keep in mind is you can feel free to disagree with it and challenge it, but take the message and internalize it so that you can grow. Because even if you disagree, something went wrong there. Someone said something that might not be true to you, but is true to them. So if it's true to them, that's really important because it's probably true to other people. If people are saying you're being rude, but you don't feel like you're being rude, you still have to change. Doesn't matter if you don't think you're being rude. You still have to figure out why you're coming across as a rude person. Yeah, so managers want to grow too, and the best feedback they can get is from the people below them, for sure. Oops, I'm not used to this new UI anymore. Cool. So let's talk about advice 2. Sorry. Oh my God. Okay. Advice 2 is you have to be flexible with your colleagues about projects and deadlines. So you want to make goals based on your efforts and not on end results. This was a huge regret of mine early in my career. I made a lot of goals based on what the results would be. So what that looks like was I said I would get promoted in the next year. And promotions aren't something I control. Promotions aren't something that I can say like, if I do everything perfectly, I'm going to get promoted. That's just not how the reality is. So building goals around promotions, building goals around what your product looks like is not going to be a way to be successful. So I would not be able to do that for sure. I would not be able to do that in the future where I would be judging my own successes based on product success, based on external things like promotions, etc. You should have candid conversations with people on your team and outside your team based on what is important. So don't think your project is always more important than literally everything else at the company, unless everyone else seems to agree with you. Of course, if someone, like let's say someone is on the COVID team at Facebook right now, they can think that their product is more important than everything else because it probably is. And probably every other team at the company agrees that it's more important. But my point here is just because you think it's more important does not mean that it's more important to the entire company. So make sure that you are having candid conversations about prioritization and you're not offended if someone's like, my product is more important than yours right now. The last thing I want to say about flexibility is build some flex time into your engineering estimates. It's always better to under promise and over deliver than the other way. You don't want to over promise and then under deliver because then people are going to think you're a slacker. But if you under promise and over deliver, if you say, for example, I'll have your homework 4 graded by next week at the latest, and I have it graded by the end of today, then you're going to be happier with me than you otherwise would. So my rule of thumb is I always give a 1.5 time estimate for engineering things compared to how long I will think it takes. So if I think it's going to take 3 weeks, I'm going to say it's going to take 4.5 weeks. Most of my managers recommend that I do that. Most of my managers say just build in 50% extra wiggle room because it's just going to take a lot longer. And then lastly, the last piece of advice is you should be proactively asking for help in unknown domains. So ask for help in anything and everything. Your only responsibility for the first 3 to 6 months, theoretically, is to soak up knowledge and be a sponge of information. No one's expecting you in 3 months to be like an expert in something in a company. There are exceptions to this. There are times where like at a small startup, you just have to be an expert on like week 2 or something like that. But most of the time, you are expected to just soak up knowledge and know a lot of things. So the way you do that is to write down everything and never ask the same question twice. Write down everything in a notebook. And I say that you should come to every single meeting with a pen and a notebook. So I carry a notebook. I don't carry a laptop because I think laptops make it feel like you might be distracted. Whereas a pen and paper, you're not going to be like doodling during a one-on-one or anything like that. So people can tell you're taking notes when you actually bring pen and paper. So I still do this with every meeting I have. I actually bring a physical notebook and a pen. And I write down everything into it. That whenever I have a question that I ask, I write down the question and I write down the answer. And you should never ask the same question twice because that's a sign that you're not actually paying attention and you're not actually learning things. Just before you ask a question, go back through your notes and see if you've already asked it. Read all of your notes and be like, oh, I already asked this, or no, this is new, but it's related to this. Come in prepared to your meetings and ask questions that are smart. There is such a thing as stupid questions. The stupidest questions are when you ask the same question twice. Don't ask the same question twice. Just don't do it. But asking stupid questions in general are okay. If you say, for example, I've never heard of an array list or a vector, that's okay. No one's going to judge you for that. Engineers are going to judge your CS classes and your CS curriculum for being like, how the hell did this person graduate from NJIT without knowing what an array list is? It's not their fault. Clearly, something was missing in their education. They're not going to judge you as a person or anything like that. And you're not going to be judged for asking a stupid question once. You might get judged for asking a stupid or smart question multiple times. So don't do that. Stay away from asking the same question multiple times. Write down the answers. And if they don't make sense, talk to them about what doesn't make sense or what you're not understanding. But don't just keep asking the same question. Today's daily quiz is going to be to come up with, okay, yeah, I like this. Today's daily quiz is going to be for you to write actionable feedback, positive and negative, two notes, one for you and one for me, one thing positive that you did well in this class, and one thing negative that you did well in this class. And then one thing positive that you think I did well in this class, and one thing negative that you hope that I did better in this class. So let me write this out. Positive feedback for yourself about CS 435, negative feedback for, I'll say constructive feedback. Constructive feedback for yourself about CS 435, positive for prof, and negative for prof. That's going to be today's daily quiz. I have not posted a link yet, so I will post a link about that. Yeah, you can submit a text submission. I'm going to open up a link very shortly for that as well. A couple questions that someone posted. In my first 3 months, I had no one to train me. I was just sitting for several weeks staring at senior developer code. It's really hard sometimes, and from your experience, how are interns normally onboarded? I've only worked at huge companies before, and that's never the case. But one thing that I would say is, even if a project is behind, you should be able to present it in a way where you're like, hey, if I could just have a 30-minute meeting every week with one of you, that would be so helpful, and I can start contributing to the project. And it's going to help so much just having 30 minutes of your time every week. And most of the time, people are going to be very receptive to just taking 30 minutes out of their time to help you do that. Especially if you present it as, using those 30 minutes, I can help you on, I can potentially help unblock you on projects, or I could move, 5 hours faster if you just help me for 30 minutes a week or something like that. So just the way that you present it and the attitude that you come in with on how it's going to help the company is going to help convince people to give you the resources you need. I have 1% battery. Let me get my charger really quickly. Any questions that we have on any of this qualitative feedback or anything else that we went over in lecture today? No questions on the feedback, none of the traits, or any of the questions? Cool. So that was it for today's lecture. Wednesday's lecture is going to be on whiteboarding, basically, and we're going to whiteboard an actual system architecture. And let's just say that we're going to basically make Uber's Dijkstra's implementation. So we're going to implement Uber's pathfinding algorithm, and we're going to do it live. So you can join in, and we'll have an hour, 20-minute architectural discussion. So this will feel like you're working at a big tech company. It's going to feel more like you're working at a smaller tech company, like a startup or something. So feel free to tune in for that, and it'll be fun. All right, I will talk to you. I'll talk to you on Wednesday, and we'll work on that together. See you.